Yeah, today we're going to talk about vibration sensors. Vibration has become one of the key components while people are trying to figure out if a machine is working in good condition or not. There are so many factors go in when you look into vibration analysis. And there are so many sensors out there which can do vibration. Here are a few things which we'll talk about when we look into vibration sensor, where generally users ask us like, hey, which vibration sensor is best and how do you identify that? So we'll start with one, data integrity. So if you're installing a vibration sensor on a machine which costs you $50,000, and you depend on this sensor to tell you like, hey, things are going good, bad, or it's very important that the sensor tells you every single time it needs to when it should tell. If it does not, and just a piece of equipment which looks fancy but doesn't do anything. So it's very important to have a product which sends the data, a correct data, every time when it needs to. So while looking for vibration sensor, this is one of the things which users generally ask for and look for it. While building this vibration sensor, we use a industrial radio which is designed for like heavy industry equipments and environments where there's a lot of noise and all. This sensor also has a retrial mechanism. So let's say it sends a data packet does not make to the final destination. It will retry before it goes back to sleep, and then next time it will retry again, and it will try its best to make sure data gets to the final destination. If it does not, let's say for some reason the receiver is down or radio link is not good and all, then at that time it won't be able to make it. But in all other cases, it will try its best to make the data there. Then the second is data harvesting. There are so many companies out there which make vibration sensor, and they will just like, okay, you can only look at if the, sorry, if the vibration is good or bad. They will not able to share or do not share all the information, what goes behind the curtains. How did you get these values? Is it correct or not? Did you do a good computing or not? So to do that, we do share the final outputs like temperature, acceleration, velocity, peak, in frequencies, displacement, but also at the same time, users can request the raw data from the device. What does that mean? Like you can send the actual raw samples which this sensor takes, and then those raw samples can be passed through any third-party analysis software, and you can figure out like, hey, if the sensor is reading correct or not. And you also have access to all the raw data. If something goes bad, you can go back in the time and you can like, hey, this machine did exactly same and this was wrong with the machine. So you can train your system to learn these patterns, and in future, based on these patterns, you can tell weeks or days in advance like, hey, this machine is going through the same cycle, so there must be something similar wrong with the machine. You can stop and you can send an alert, and the users can get the data and all that. After that, adaptability. This is quite important. Like when you get a sensor, they they generally have like, hey, this sensor will work into this range, but not all the motors are same. Some motors will run really slow, some will run in medium speed, and some motors will run at really high speed. You can't have one sensor which you can put at everywhere and they're like, okay, it will work at everywhere. That's quite not possible. It is always in a range. So what we do is we allow users to tune the frequency of the sensor based on the machine frequency. According to Nyquist equation, your sensor should be sampling at least at 2.56 times of the machine frequency. So based on that, we create a table which you can find in the product manual here. And based on that, you can tell like, okay, for this machine is running at this frequency, so I should be using these settings to get the best results out of the machine. So if you scroll down, you'll find there's a table all the way, and here you go. So based on different machine frequencies and RPMs, you can choose different range, and that will give you best results for that particular machine. Next, we'll talk about cloud or local computing. This is also one of the key components when people talk about vibration sensor. And generally, vibration analysis was always done using handheld meters. So a user will go around once a month, once a quarter, every 6 months, check his machine. Okay, looks good, not look good, and then they'll just move on. The problem is that by the time you reach back and you check back the machine after 6 months, the machine might fail in the meantime. And sometimes the cost could be quite high to repair or replace the machine. In that case, these sensors come really handy because they can keep taking samples, live samples, after every few minutes, 24/7 and 365 days. And based on that, you can decide, you can check the pattern, and you can see if the data looks good or not, if there needs to be action or not. Uh, there are so many ways to collect the data. NCD only makes hardware. It gives its users full choice of like, hey, you can use any cloud platform or any local non-cloud platform. Sometimes users don't want to go to cloud. You can just want to store data locally on a computer, and you just like, hey, it does not need to leave my building. That is also possible there. We have so many options if you click on purchasing where you can send the data. If you want to go to MQTT or a cloud, any cloud, you just go with MQTT. If you want to go to Amazon, use AWS gateway. If you want to go to Locent, use this gateway. If you want to go to Microsoft Azure, go this one. If you want to use a Wi-Fi one, go with this one. If you want to use Wi-Fi, LTE, Ethernet, and all that, then go with this one. USB, if you want to connect to a computer, you already have a gateway. Use like, I don't want one more gateway. I already have a Dell, HP, or some gateway. You can just, or you have a computer, you can just plug the USB one, then you can get data there. Same goes for Ethernet. Same goes for RS-485, RS-232. There are tons of options of collecting data locally as well as cloud. So you're not bound by a few options or it's only one option. You have so many options there. Then any hidden cost. Nowadays, the hardware is also going on a SaaS module where there will be a recurring cost every month, even though you paid for the hardware, but they still will be charging you a small fee to use the hardware or even retrieve the data which is sensor is taking. Generally, NCD only makes hardware and you pay a one-time fee and then it's your hardware. You can go to any cloud, any service, or you don't want to go, it's your choice. There is no hidden cost associated with the sensor. Ease of installation. When you're installing only one or two sensors, it's not that big of a deal. You can like, okay, it's pretty easy, I can install. But once it goes to like 500 or 1000 or 10,000 sensors throughout your 20 facilities, then you need to care about how to install, how easy the installation is. In all those cases, like our products are extremely easy to install. As you can see in picture here, it has a main box. This box contains all the electronics, radio, power supply, batteries, other electronics, and it has an antenna, and then it comes a probe, and the probe is like 2 meter long. So in a lot of places, it gets a little difficult. You can't say like, okay, all my installation will have a good room and RF will be good and all that. So probe makes it really easy to install where you are difficult to reach. In those places, you can install the probe and you can install the main box out of the way where it can reach the radio and you can get a good signal also. The probe has few mounting options we'll talk about in a second. So this probe is metal, stainless steel. It has a male quarter-inch NPT, so you can put install in a thread, and then it has a female quarter-inch 28 UNF, just like this mounting, so you can screw in there. And then we have a magnet option, which you can install like a magnet and you can mount magnet. Magnet is one of the easiest one, but in all recommendation, if you're installing a vibration sensor, it's best to screw in if you can. If not, then this magnet is 50 pound, so it's a very strong magnet. It can still, but magnet do not work very well when temperature rises, so you have to keep that in mind. So ease of installation is very important, and you can take a look here. This is X marking, which denotes the X-axis. Let's go our next point, wireless range. NCD uses 900 megahertz as its frequency. There are a few reasons. There are a lot of reasons to use it, but here are a few. This is the one of the least crowded radio band out there. You will find so many equipments, computers, machines, phones running at 2.4 gigahertz and 5 gigahertz. So if somebody makes a sensor with BLE power, it will not work very well. You will have to put so many gateways all around, and you will always have a range issue, dropping signals and all that. The 900 megahertz can go through walls. It can travel quite a bit distance, so it makes it ideal for industrial environment. The RF band is not crowded. It means you will not have had problems with losing the packets. So that's why we use the 900 megahertz. In indoor, it can go between 1,000 to 1,200 feet, and outdoor facility, it can go up to 2 mile range. So it's a lot better if you compare to BLE and Wi-Fi signals. Then we'll talk about battery life. As I said, if you're installing only few of them, then it's okay. You can change battery every few years, and it's okay every year or so. But if you're installing tons of them, then you don't want to go and change battery every 6 months or a year also. NCD hardware has extremely long battery life. If you go by other standards, like if you're sending data after every 2 hours, then the battery can last over 8 years. So you have choices how frequently you want to send data and where you want to send the data. The last pack we did not talk about is what kind of data a vibration sensor sends. So this sends quite a few kinds. We have few other videos, but it sends acceleration, velocity, displacement, frequencies. Based on all these four parameters, you can tell how a machine is performing. If there's something wrong with the machine, or something is going bad, or is a looseness, or bearing is going bad, or mounting is not good, or some coil is going bad, and its temperature is extremely increasing. So all these parameters can work together and can give a really good picture, an idea about how your machine is working. These are very few basic things which you need to take a look or keep in mind if you're looking for a vibration sensor. If you have any questions, just feel free to reach out to us. Thank you.